हेलो बच्चों। तो आज का प्रॉब्लम है हमारा, वी हैव टू स्टेट दी आइगन्स पोस्टुलेट ऑफ वेव थियरी। तो आइगन का पोस्टुलेट क्या था वेव थियरी को लेकर, और हमें स्केच करना है वेव फ्रंट्स को स्केच करना है पॉइंट सोर्स ऑफ ए लाइट के लिए और एक लीनियर सोर्स ऑफ लाइट के लिए, जैसे एक स्लिट से बाहर निकलता है। क्लियर है? तो एकदम स्ट्रेट फॉरवर्ड क्वेश्चन है। तो हम पहले पोस्टुलेट्स देख लेते हैं, हाइगन्स पोस्टुलेट्स। हाइगन्स पोस्टुलेट्स, हाइगन का पहला पोस्टुलेट था कि लाइट ट्रेवल्स इन द फॉर्म ऑफ वेव फ्रंट। वेव फ्रंट के फॉर्म में ट्रेवल करता है और एनर्जी वो ट्रेवल करता है इन द फॉर्म ऑफ वेव। दूसरा, अगर वेव्स है तो वेव्स को ट्रेवल करने मीडियम की जरूरत होगी। तो आइगन ने अज्यूम किया कि देयर एग्जिस्ट अ मीडियम called as, he named it ether. This was considered by Huygens to justify the propagation of light in the space. And third assumption is every point in the wavefront acts as the source of disturbance, and due to this disturbance there is a spherical sphere formed which give rise to, which forms spherical waves. These spherical waves are called as the secondary wavelet, and the locus, the collection of points of all the points of the wavelets in the forward direction is called as the wavefront. So I guess you must be clear what is the term wavefront means. It's just the collection of points on the wavelets. And one more postulate we can say that he also said that the wave and the wavefront are always perpendicular. And using these postulates, several phenomena such as refraction, reflection, interference, and diffraction were explained. But in this, the drawback of these postulates was few, that it couldn't explain or distinguish between the longitudinal wave and the transverse wave, because of which few properties of light were still to be proved. And now if we start to sketch the wavefront point source, if we take point source, this is the diverging source. Like consider this is the point source, and you will get light in all possible direction. Light will travel in all possible direction like this. We are only seeing this forward direction. It doesn't mean that light doesn't travel in the backward direction. it also travels in this direction also. So if we consider, due to this source there is a spherical disturbance around it. Consider this as a spherical disturbance. We are here projecting in 2D, projecting 3D in 2D. We have to always keep that in our mind. So each point in this disturbance acts as an, it doesn't match, so let's take some different, yeah. Each point in the wavefront, this wavefront acts as the disturbance, point of disturbance, and this create a spherical waves around itself. These are the spherical waves. Since we are doing it in a 2D, it's seem to be a circle. So these are the wavelets. These are the spherical wavelets we were talking about. And if we take the locus of all the points, like the in the forward direction of the wave propagation, and if we add all this, if we connect all these points, if we connect these points, we will get a new wave front. This is how we construct different wavefronts at a given instant of time. So this would be a secondary wavefront. If we consider this as the primary one, then, and now these wavefronts will have n number of disturbance, and those will create n number of different wavelets, and locus of all the points in the wavelets gives are the next wavefront. So this type of wavefront is called as the spherical wavefront. So for a point source, wavefront will be spherical. Now let's see for a linear source. Linear source, you can take an example of a tube light in your house or something like that, like a slit in a in a diffraction experiment. We take slit with, so you can consider that also. If this is your slit primary source, then there would be, this would be small disturbance in that, and if we construct waves, if we construct waves around them and get the points, we will get the wavelength, we will get the wavefront we were looking for. So this is the wavefront. And similarly, if we take points, different points, and we get these spheres done, here also we are projecting it all in 2D. The 3D figures is been done in 2D. So for a slit, this is what we defined as the wavelength. This is our wavefronts. This one and this one are the wavefronts. So this type of wavefront is called as the planar wavefront. All are similar except the shape. So for a linear source, wavefront will be planar. So I hope you understood what's Huygens postulate and how using those postulates we have built wavefront for point source and also for the linear source. I hope you understood this problem, how to tackle this. Thank you.